Testing. All right, so this is number 15 in our homework set this quarter. So we want to compare our basic geometric sequence, or geometric sequence and convergent function to this function right here. And this has a center at 5. So, all right, so let's think about that for a minute. This denominator here, now I want to just rewrite that. So I have x minus 5 squared in the top. In the bottom, I'm going to rewrite it as x squared minus 10x. Plus 26. Does that factor? Let's see, 26 is what? 2 times 13. All right, so this does not factor, but we could complete the square on that. Yeah. So if you don't remember completing the square, x squared, minus 10x plus 26. I'm just going to pull the 26 off to the side there. I want this to be a perfect square. To do that, I take half the middle term, so negative 10 divided by 2. That gives me negative 5, and then I square that. Okay. So what I'd like this to be right here is a plus 25, because then this is a perfect square. So to compensate for adding 25, I'm also going to subtract 25 and clean that up right there, which is now a 1. This is the square of x minus 5. And if I add 1 to that, then that gives me x squared minus 10x plus 26. So my original function here is now x minus 5 squared divided by 1 plus parentheses. I'm going to write it as 1 plus x minus 5 squared. So I'm starting to get it to look more like this right here. Got the x minus 5 squared in the numerator. Which probably just going to be a multiple. All right, so what are the differences here? I have a plus here, I have a minus there. So what I want to do here is I'm going to do 2 things. I'm going to replace the x up here with a negative parentheses x minus 5 squared. So that's going to get replaced here and here. And then to deal with the numerator, I'm just going to multiply that up on both sides of this. And that will morph this original one into this new one that I have here. So my series then, I'm going to multiply the outside of the series by x minus 5 squared. And then as far as my sum goes, I rewrote this to kind of look like that. To get them to match, I would have to do this substitution, which means replace x with this right here. So instead of an x to the n, I'm going to have a negative x minus 5 squared to the n. Now I can clean that up a little bit. The negative to the n, I'm going to pull that out as a negative 1 to the n to make it look alternating. So I've got x minus 5 squared times the sum as n goes from 0 to infinity. I'm pulling out the negative 1. It is to the power n. It's going to make this alternate. And then a power to a power is multiply the powers. So that means I'm going to have an x minus 5 to the 2n. We'll do that one series right there. So again, this section was about, and the next section was about doing these substitutions, multiplications, differentiation, or integration. Try and get one series to morph into another. So that should be the series for this right here. Interesting.